Yo, what's up? Ricky Sanders here. If you live for fast cars, greasy hands, and solving problems under the hood, welcome to your new favourite spot. I'm all about real fixes, no BS, and showing you how to keep your ride running like a champ. So go ahead, smash that like button, hit subscribe, and let's make some noise in the garage. Enough talk, let's get wrenching.
Automobile engines are extremely diverse. The technology that is used in the development and launch into production of power units has a rich history. The requirements of modernity force manufacturers to annually introduce refinements and modernize existing technologies in their projects. The internal combustion engine has a device and principle of operation, capable of providing high power and a long period of operation. The user is required only the minimum necessary maintenance and timely minor repairs. At first glance, it is difficult to imagine how the engine works. Too many interconnected mechanisms are assembled in one small space. But with a detailed study and analysis of the links in this system, the work of the car engine turns out to be extremely simple and understandable. The engine of the car includes a number of components that are important and ensure the performance of the working functions of the entire system. The cylinder block is sometimes referred to as the housing or frame of the entire system. The description of the engine does not do without studying this element of the design. It is in this part of the engine that a system of connected channels is arranged, designed for lubrication and creating the necessary temperature of the internal combustion engine. The upper part of the piston housing has channels for rings. The piston rings themselves are divided into upper and lower rings. Based on the functions performed, these rings are called compression rings. The torque of the engine is determined by the strength and performance of the elements considered. The lower rings of the piston play an important role in ensuring the life of the engine. The lower rings fulfill two roles. They keep the combustion chamber tight, and they are seals that prevent oil from entering the combustion chamber. The car engine is a system in which energy is transferred between mechanisms with minimal loss of its value at various stages. Therefore, the crank mechanism becomes one of the most important elements of the system. It ensures the transfer of reciprocating energy from the piston to the crankshaft. In general, the principle of engine operation is quite simple and has undergone few fundamental changes over the period of its existence. This is simply not necessary. Some improvements and optimizations allow to achieve better performance results. The concept of the entire system is unchanged. Engine torque is generated by the energy released during combustion, which is transferred from the combustion chamber to the wheels via connecting elements. At the injectors, the fuel is transferred to the combustion chamber where it is enriched with air. The spark plug creates a spark, which instantly ignites the resulting mixture. In this way, a small explosion occurs, which ensures that the engine works. As a result of this action, a large volume of gases is formed, stimulating the progressive movements. This is how the torque of the engine is formed. The energy from the piston is transferred to the crankshaft, which transmits the movement to the transmission, and after that, a special system of gears transfers the movement to the wheels. The working order of a running motor is simple and, with the correct connecting elements, guarantees minimum energy losses. The working scheme and structure of each mechanism is based on the conversion of the created impulse into a practically usable amount of energy. The engine resource is determined by the wear resistance of each link. The following parameters serve as determining parameters for categorizing power units: displacement, number of cylinders, system power, speed of rotation of nodes, fuel used for operation, and others. It is easy to understand how the engine works. But as you study, new indicators that raise questions pop up. So, you can often meet the division of engines by the number of cycles. What is this and how does it affect the performance of the machine? The design of a car engine is based on a four-stroke system. These 4 cycles are equal in time. During the whole cycle, the piston goes up twice in the cylinder and down twice. A cycle starts at the point where the piston is at the top or bottom. Mechanics call these points TDC and NMT, top and bottom dead center, respectively. Tack number 1 is intake. As it moves downward, the piston draws the fuel-filled mixture into the cylinder. System operation occurs when the intake valve is open. The power output of a car engine is determined by the amount, size, and time the valve is open. In certain models, the operation of the gas pedal increases the period of time the valve is open, which increases the amount of fuel entering the system. This arrangement of internal combustion engines provides a strong acceleration of the system. Tack number 2, compression. At this stage, the piston begins its upward movement, which leads to compression of the mixture received in the cylinder. It liquefies exactly to the volume of the combustion chamber. This chamber is the space between the top of the piston and the top of the cylinder when the piston is at TDC. The intake valves are firmly closed at this point. The tightness of the closure determines the quality of the compression of the mixture. If the piston itself, or the cylinder, or the piston rings are worn and not in proper condition, the quality of operation and engine life will be greatly reduced. Tack number 3, working stroke. This stage begins at the TDC. The ignition system ensures that the fuel mixture is ignited and energy is released. The mixture explodes and energy is released. And by increasing the volume, the piston is pushed downwards. The valves are closed. Technical characteristics of the engine largely depend on the flow of the third tact of the motor. Tack number 4, release. The end of the cycle of operation. The upward movement of the piston ensures the expulsion of gases. Thus, the cylinder is ventilated. This tact is important to ensure the life of the engine. The engine has a principle of operation based on the distribution of energy from the explosion of gases, requires attention to the creation of all components. The operation of the internal combustion engine is cyclic. All the energy that is created in the process of doing work on all 4 tacks of the pistons is directed to the organization of the car. Variance of internal engine designs. The characteristic of the engine depends on the peculiarities of its design. Internal combustion is the main type of physical process occurring in the motor system on modern automobiles. Over the period of development of mechanical engineering, several types of internal combustion engines have been successfully realized. The design of the gasoline engine divides the system into 2 types, injector engines and carburetor models. There are also several types of carburetors and injection systems in production. The basis of operation is the combustion of gasoline. The characteristic of the gasoline engine looks preferable. Although for each user, there are personal priorities and benefits of each engine. The gasoline internal combustion engine is one of the most common in the modern automotive industry. The way the motor works is simple and does not differ from the classic interpretation. Diesel engines are based on the use of prepared diesel fuel. It enters the cylinders through injectors. The main advantage of the diesel engine is that there is no need for electricity to burn the fuel. It is only required to start the engine. The gas engine uses liquefied and compressed gases, as well as some other types of gases. In conclusion, the internal combustion engine has played a pivotal role in shaping modern transportation and industry. Its ability to convert fuel into mechanical energy has powered countless vehicles and machines for over a century. While advancements in technology and a shift towards more sustainable energy sources are on the horizon, the legacy of the internal combustion engine remains significant. Understanding its mechanics and impact helps us appreciate the innovations that have brought us to where we are today, as well as the challenges we face in the transition to greener alternatives. Thank you for watching, and we hope you gained valuable insights into this fascinating topic.